Alright, so now I got the meter here, so we can use this as continuity checking. Yeah, this alright, so if you follow this wire here, you're gonna see this the green wire is just grounding. Okay, we check this the ground, so when we do the looking for the ground, so we can see that okay, this is the ground, the green ones. Okay, well, make sure you remember where's the ground spot of the device here. So in the back, when you flip that, you need to check the leakage. That's what is the ground port is going to be from the other side of the cover. Okay, so now when you look at the white one, so this is the white on this side, you're going to see the white one come to the one side of the transformers, actually at the bottom of the transformer. Okay, and then the black one actually come over here. So the black one, the black wire here, go connect it to the fuse. Then from the fuse is gonna go to that one side of the transformer. So the transformer, it should rectify, or not rectify, I'm sorry, to stepping down, because the transformer, the voltage is coming in as a 110, right? And then this transformer should step it down to around, I would say, a little bit over than the battery 12 volt. This should be around 14 to 15, something like that. We can check that when you plug this thing in on the electrical safety analyzer here. So we can just use this as a power source, right? So let's looking at okay, let's see what is the voltage this thing is, right? Let's see okay, let's see where we, okay, that's the volt, millivolt, the range. And let's see. Let's see, if we turn this on. Oh, sorry, let's see. Okay, hang on. We're gonna have to go to this. I'm not doing point to point. We go back to ground. Let's see, let's get the power supply to this. Okay, let's go back to home. Go back to home. Let's see. Okay. Alright, so this machine is on. Okay. So we got powers to the pumps. Alright, we got the power to the pumps. Yeah, let's see, can you see that? Yeah. Got power to the pumps, and then we see that what is the volt. We got about 14. No. Yeah, 14.5. Yeah, 14.6, something like that. Stepping down. So we expect that when this AC voltage going to this rectifier, which is, you see that a bunch of diodes down there. So that's gonna rectify into DC voltage. So that DC is gonna feed back into this yellow and greens into the DC voltage. That should charge this battery. So the voltage, which is supposed to be DC, we should expect to see somewhat above, more than 12, which is it read about 13.78. So that's telling us that the charging circuit is good. The power supply part of the unit itself is working, because we got the step down transformers from 110 is going to 15 something, and then it's going down to the rectifier. From the rectifier, convert the AC voltage into the DC charge. This battery is around 13 something. All right, so that is working fine. So in down here, we're gonna see what happened is we have a stepper motor. The stepper motor is here is before we go into the stepper motor, let's looking at on the back of this unit itself. See, we have the volume control in the back here, so this can control the volume of the buzzer. This is the buzzer of the units. Okay, this is the buzzer of the unit. Okay, and this is the volume, so you can turn the volume up and down. Yeah, so that's reduce the volume of the buzzer. Okay, so that's that. Yeah, that's pretty much on the back side of the pump itself. Okay, now let's look at on this part of the pumps. Okay, so this part of the pump here, okay, you have a stepper motors. We have a processor, and this is a processor to do programming, to programs, the volumes and the rate, okay, and also provide the display and alarms. When the volume is complete, when occlusions occur, it will go into alarms. Now also, there's a sensor over here. We call this a drip sensor. Drip sensor is that the function of the drip sensor is to detecting the droplet of the fluid. So if the fluid stopping, it will actually give us alarm, say okay, it's volume complete, something like that. So this is the drip sensor here up in the front. All right, okay. So let's see if I'm going to turn this off. Okay, so we turn this unit off. Okay, so now you can see that it's not a whole lot of the complication of this particular unit. What I want to do is I'm gonna take up the power. Now when you work on this, make sure you disconnect the power just for the safety. And what I want to show you is the next thing is, this is very important part of the general medical devices for the portable. You have a power supply parts, you have a charging circuit down here for rectifier, some here, okay, and then step down transformers is always part of this, the system, part of the power supply system of the unit. Okay, so we always check to see if the high voltage is coming in, so low voltage is coming out, and the DC voltage is always coming out charging this the batteries. Okay, so this is very important, as to understand this, and can be easily checking when the unit is have no power and things like that. You can actually come in and check on this. Okay, all right, so the next thing we're going to look at it, we're just gonna disconnect this part of the power. You see, disconnected this in the powers, and this one is a control part. So this is part of the controller's parts, and let's see here we have Okay, that's the, as actually this is part of the ground for the stepper motors. Okay, what I'm going to show you is, well, you see part of the display. Okay, parts of the display here, since the unit have the, a couple display, and this is part of the input. All right, so this is the input part of the I can move this so you can see it. So this is the input, and this is just the display condition. This is the LED display also. So this is not a sophisticated display system. So what they do is, they add this all together, all right? They integrated the display together, all right, with the processor unit. So basically, most of the time on the particular unit, when there's a problem with it, we basically we going to replace the whole circuit board. Okay, instead of do the component troubleshooting, it's gonna waste a lot of time for us. Okay, I'm gonna quickly see if I can open this. You can see, oh, that's part of the display. Let's keep that connect for now, and I'll flip this, right, open so you can see it. Yeah, hopefully we have some time. Okay, I think it's a 4 screw, right? Take it out. Okay, so we got 4 screw. We'll pull it out. Okay, so we see this one right here. So this ribbon connector is connect to the input. The membrane keyboard, right? This membrane keyboard for the front. So this membrane is sometimes this membrane keyboard here, defective. It's got hole and the damage, so we can rip it off and put a new one on that. Okay, so that's the, and now let's look at this. Okay, so this part here, okay, you can see this is integrated as processor board on this side and the display board on this side. So we have the LED display, and then also the diode, LED diode here to show the indicators. LED also is showing the status of when we're running the pump. So it's pretty simple designing. Okay, so it's got, and another thing is we have microprocessor here, and we have this processor, and this is like a EEPROM, the programming to run it, and then we have the rectifier, and also they have a small, I can see it, some sort of small rectifiers for the run this processor, because some of this processor here is only run at we call that 5 volts voltage. So basically, some of this rectifier part of this will actually stepping down and then rectify from 15 volt into down to like 5 volts, plus minus 5 volts DC to run all these small components. Okay, so that's about it. That's pretty much the brain and that the part of the control of the whole system. Okay, and I'll put this thing back. Okay, let's see. Okay, let's see. This is part of. Okay, this is part of the controller system. Right, sensors. To that, and this is part of the power supply system. Make sure everything line up, pin connector line up. So you need to make sure that before you push it down, yeah, all the pin connector is kind of nice and lined up, so you don't accidentally bending it. Okay, they all connect together. There's control, everything's in place. Well, so ground, connect. Somehow one of these lock nut came loose on the transformer. We're gonna have to kind of tighten this, right? Because the thing can move around quite a bit, so it's typical normal. Just this thing gonna kind of loose. So let's see. Let's use that. Okay, I have to use a plier. So. Okay, now we got that tight, then we'll put this thing back together. Right. Alright, so we got two short screws for the top, we got long screw at the bottom. Okay. Okay, so we got that. And one more screw over here. I think it's make sure that, yeah, because we don't get the good, yeah, we need the longer screwdriver, so let's see. Yeah, well. Okay, for the sake of time, I'm just gonna show you. When we're done, we need to plug the unit in, right? Turn the power on to see if okay, let's see, where is that? Chassis leakage. Okay, let's see. let's see, here we have, let's see, leakage, let's see, okay. Okay, so this one have the post back here, 0, and let's see, we open the ground. Yeah, so we got leakage currents back here as the 6.5 microamp as open ground. Okay, so that's how we checking leakage currents on this device. All right. Hopefully you learning something, and I'll finish up and put this screw back in here. I think it's still not tight enough, so hopefully you learn something from this. Okay, all right, thank you, bye.